Hi, my name is Milan. I'm a software architect and Microsoft MVP, and in this video I'm going to show you how easy it is to start building AI-powered applications in .NET using Amazon Bedrock and Semantic Kernel. I'll give you a high-level introduction into Amazon Bedrock and how you can start using it to build generative AI applications. First, let me introduce you to Amazon Bedrock, which is a fully managed service offered by AWS, and it aims to simplify the development of generative AI applications. I also want to say a huge thank you to AWS for sponsoring today's video. Now, what does Bedrock do for you as a .NET developer? Well, it offers access to a series of foundation models from leading AI companies such as Anthropic, Cohere, Meta, Mistral, Stability, so you can start using many of these models right out of the gate. You can also customize them with your own data and create an AI model that is tailored to your specific needs. Now let's jump into the AWS console and I'll show you how to get started with Amazon Bedrock. So I'm in the AWS console, and for this demo I'm going to use the US East 1 region, and let's head over to Amazon Bedrock. If you've recently visited this service, it's also going to show up on the homepage directly. So here is Amazon Bedrock, the easiest way to build and scale generative AI applications with foundation models. So let's go into Bedrock itself, and from the default user interface you'll be greeted with a bunch of options to explore Bedrock further, such as taking a look at the model catalog, some models that are currently in the highlights such as Anthropic's Claude, Llama from Meta, and Amazon's Nova. However, the first thing that I suggest that you do is to scroll all the way down and go into model access. So here you're going to see what are the models that are available in Amazon Bedrock for your AWS account. You can see that there are 55 base models available, and I currently have access to most of them. However, this may not be the case when you visit this page. So you will have to pick and choose which models you want to use and then request access for them explicitly. Luckily, this is pretty straightforward. You just request access and it's granted within a couple of minutes, and you can see a nice little example here of a new model called Pegasus 1.2, which is available to request. So I can click on request model access. It's going to open up a UI screen like this, and you just want to make sure that you have the specific model checked that you want to request access for. Then you can click next, possibly go over any end user license agreements which you'll have to accept, and then you'll be granted access to this specific model. So I'm going to cancel this because I don't want to add a new model. However, here you can see what are all of the models that we have available. So we have models from A21 Labs, from Amazon themselves. We're going to be using some of these in the Titan family in our practical demo when we jump into the .NET applications. Then you can see some models from Anthropic, such as Claude Haiku or Claude Sonnet. You also have access to Claude Opus, and we have models from Cohere. Of course, DeepSeek is also there. Then we have models from Meta. These are going to be the Llama family of models. And then we have models from Mistral AI, Stability AI, and last but not least, 12 Labs. So that's how you can get access to the specific AI models in Amazon Bedrock. So once you've taken care of that step, you can go ahead and try out some of the models that you're interested in the playground. So I can go ahead and click on the chat or text playground, and the first thing I have to do here is select the model that I want to use. So let's say I go into Anthropic and I choose, for example, Claude Sonnet 4 and click apply, and this is going to set the Claude Sonnet 4 as the model for my request. Then we can customize this with some system prompts that we always want to pass along to the model. We can tick this box to include model reasoning. However, be aware that this is going to expend more tokens than a regular request. The screen is a bit flickery, so forgive me for that. It's kind of out of my control, but we do have a couple of more parameters that we can configure here before we send the request to the AI. So then I'm going to write my prompt, and I'm going to say generate an ASP.NET Core 9 middleware that I can use for exception handling. And I want to see how good this model is at producing some code, which is a practical use case for AI. So I'm going to run this, and then this is going to start generating the response from the AI. And you can see I get an exception handling middleware in the response pretty quickly. You can see the cost for this request, which is 25 input tokens and 1024 output tokens. And you can also see the latency for this request. Now let me zoom out a little, and we should be able to see the entire exception handling middleware right here. So then you can figure out if this is something that you want to use in your applications, or fine-tune the model with some additional requests to explain how you actually want to use this in practice. Nonetheless, this is a decent example of code generation. You can also switch to single prompt mode, and I'll use the same model from Anthropic, and I'm just going to ask it what is the current version of .NET. And the reason I'm doing this is because I want to show you the API request, which is an actual example of an AWS CLI request that you can use for the Bedrock runtime service. So we're using invoke model and specifying the model ID. You can see that this is using an inference model for Claude Sonnet 4. And then here's our request body. It contains the prompt that we passed to the AI, asking it what is the current version of .NET, but it also contains the maximum tokens, the temperature, top K, top P, stop sequences, and the request also contains which AWS region to use. Now, if we take a look at the response, you can see that the cutoff date for the AI itself is April 2024, which is when .NET 8 was the latest version of .NET, even though we are now in 2025. And the latest version is .NET 9 with .NET 10 coming out soon in a matter of months. Now, other than the chat or text playground, let me show you one more example, which I think is going to be quite interesting, and that is image or video generation. So here I'm going to use a model from Stability AI that I can use on demand, and I'm going to write a silly little prompt saying a frog floating on a leaf in the middle of the lake, and the frog is also the king. So let's run this and see what we get in response. And you can see that we get an image generated like this. Now, let me show you what happens if I switch the model to use some of the available models from Amazon. And let's say I use Titan Image Generator G1 and pass it the same prompt. Now, you can see in this case, we are getting 3 example images instead of 1. And then let's see what the model produces once it generates the images. So you can see that we are getting some more photorealistic images generated by this model. However, it's still not including the crown that I was expecting it to do when I specified that the frog is the king. Nonetheless, this is just a quick demo of what you can do from the playground. Now, let me actually show you what you can do from the code to integrate with Amazon Bedrock. I'm going to start from a basically empty .NET 9 console application, and the first thing I want to do is to install a few NuGet packages. So let's go ahead and look for Semantic Kernel, which is an abstraction built by Microsoft that allows us to integrate with large language models. So I'm going to install Microsoft Semantic Kernel, the latest stable version. Now I'm going to look for Semantic Kernel connectors, and I will have to tick the includes pre-release box to be able to find the specific connector that I'm looking for, which is the connector for Amazon. So I'm going to install that as well. And then you want to install the Amazon Bedrock SDK. So let's look for Amazon Bedrock, and the library that you want to install is the AWS SDK Bedrock Runtime. So let's go ahead and add the latest version. So with these few libraries in place, we can start building our AI-powered application. So the first thing I'm going to say is builder services, add chat completion service, and the one that I'm looking for is the Bedrock chat completion service. Now here we have to specify the specific model ID that we want to use, and let me show you how you can find the model ID for the model that you want to be working with. From the AWS console, you can go into model catalog, and then you can filter down to some specific model that you want to explore. So let's say I narrow down the choices to Amazon, and then I can additionally filter to text models. And you can see what are some of the available models. I'm going to choose Titan Text G1 Premier, and if I go into this model, I can see some additional information, and what I'm interested in is the model ID. So I'm going to copy this value and go back to my application, and I'm going to specify this as the model ID. Then I'm going to register another service. I'll say builder services, add transient, and I'm going to return a new instance of the semantic kernel. So I'll just say return new kernel and pass in the service provider. So then once we build our application, I can say application services get required service, and I want to resolve an instance of the kernel. So let's store this in a variable, and then I can use the kernel, access its service provider, and resolve a chat completion service, which we can use to start building some generative AI applications. So in this example, I'm going to show you how you can interact with an LLM using chat mode, and then we can extend this with some more complicated use cases. So the simplest example would be creating a chat history instance so that we can track our conversation with the large language model. We can add a question to the chat history. Let's say add user message. And instead of saying, hello, how are you? Let's say, what is the latest version of .NET? Then to send this off to the large language model, you can say chat completion service. And I'm first going to call get chat message content async. So here we're going to pass in the chat history, and we can also pass in the kernel instance. This is going to generate a response that we can store in a variable. And finally, we can write this response to the console. So I'll say console write line, and I'm going to pass in the response object directly. So let's go ahead and start this application. Now this does assume that you are authenticated with Amazon Bedrock locally, and when adding the Bedrock chat completion service and the specific model, you will need to have this model enabled in your Amazon Bedrock for the specific region that you are authenticating for. So let's go ahead and start this, and we should see some logs from the AWS SDK that it's found the credentials on our file system, which is how I'm authenticating. And finally, we can see a response from the large language model describing what the current version, according to the model, of .NET is. And this model seems to have an even earlier cutoff, with .NET 7 being the latest version according to it. So this is the simplest example. Now, how can we expand this to implement a proper chat model with a large language model? To save us some time, I'm just going to drop in the complete implementation, and then let's walk over it. So we're still creating a chat history, except this time I'm using a while loop where we are going to ask the user for a prompt. This is going to be recorded in the user input, and if the user input is null or white space, then we're going to exit the while loop with a break statement. Otherwise, we're going to add this as a user message to the chat history. Then we're going to pass this along to our large language model, which is using Amazon Bedrock, and in this case we have Semantic Kernel facilitating the communication. So we're going to get back to response. I'll make sure to add this to the chat history and then write it to the console. So let's go ahead and run this version of the application, and let's see what I can do with the Titan text model from Amazon Bedrock. So I'm going to ask it, how do I implement API versioning in my .NET 9 controllers? And then I'll say, just give me the most important code snippets. So let's send this off to the model, and in this example it's going to take some time to get a response from the AI. Now, I know you're probably used to some streaming response that you get in most web applications that integrate with large language models. I will also show you how we can build this, but first let's examine the response from the AI. So it's suggesting to use Microsoft ASP.NET Core MVC versioning. I do believe this package was deprecated, but if we take a look at this example here, adding API versioning, this is consistent with the latest version of the ASP versioning library. Then we have adding an API version attribute to the controller. This is also correct, as well as including the version in the route if we want to use URL versioning. So this is definitely useful. And then I can continue chatting with the large language model, and I can ask it something controversial. So let's say, doesn't our fielding suggest not to use API versioning at all? What about API change management? And I want to see what the model is going to recommend when I prompt it with something like this. And the general consensus when building a REST API is that you want to evolve the API design over time while maintaining backward compatibility. And then there are a couple of best practices in the end for how you can do this, but we're going to leave this discussion for a separate video. Now let me show you how we can update this example to use streaming for the API response instead of waiting for the entire response to be returned from the large language model. So I'm going to drop in the code snippet for that, and I will leave both of the code snippets available in the final source code, which you can grab completely for free from the pinned comment right under this video. So what's different here? Well, we still have a chat history. There's a while loop, just the same as before, and basically everything is the same except the API that we are calling. So now we're using get streaming chat message contents async, and this is going to give us an iAsync enumerable that we can iterate over using a wait for each, and this is going to yield a chunk or a part of the response every time we get something from the large language model. So we're going to write the chunk to the console, add it to the full response, and then we need to make sure to add the full response to the chat history. So let's run this example and you'll see what's different. So I'm going to ask it, how can I connect my EF core database context to an Amazon RDS Postgres instance? Just give me the relevant code snippets so I can start building this ASAP. And then you can see how the streaming works right as we speak. And we're getting the response from the LLM in small chunks until we get the complete response. So then we can go over what the LLM produced. So it's suggesting that I should use MPG SQL and Amazon RDS for Postgres to connect. Here's an example database context. And then we have how to configure this using a connection string, which should point to the specific RDS instance. Now I'm going to ask it another question, which I think might be interesting. And I'll say, let's say we have a read replica. How can I connect to the primary for writes and the read replica for reads? So then the AI is going to start streaming the response, and we can start looking at the suggestions here. So you can see it's suggesting that we have two connection strings for the primary instance and for the read replica. Replication is something that's offered out of the box with Amazon RDS. However, in this example, I can see some hallucination. I'm pretty confident that there is no use application intent method available on the SQL options. Correct solution would have been to use a separate database context for the primary connection and then for the read-only replica. Nonetheless, this is just an example of how you can build a streaming chat application with Amazon Bedrock and Semantic kernel. If you want to learn more about using Amazon Bedrock, I'm going to leave some useful documentation links in the description of this video. And if you want to continue sharpening your AI skills, then take a look at this video next, where I show you how to build an image recognition application in .NET using MEAI. Make sure to smash the like button if you enjoyed this video. Thanks a lot for watching, and until next time, stay awesome.